did we get done with
when
these
you came
notes?
in. It's the thing that tells you what to do.
That's mine.
So looking at that definition, it says that the sides are proportional. What does it mean to be proportional? So yesterday we looked at proportions, right? And we kind of looked at them as they were they looked like fractions, but they're two ratios, we call them. And one was like reduced and the other wasn't, right? So it would mean it was one of those proportions that was a true proportion, that it was equal when we did that cross product. And then our corresponding angles have to be congruent. Because similar polygons are like polygons that have a dilation has been performed on them. So if even looking at our first example here, if we flip this one kind of the other way and look at those, do you see that one is a smaller version of the other? So it looks like this one is just this one that's grown up, that's been expanded. So part of what we're going to do is be looking at these and decide, is it really similar? Because have all parts grown kind of simultaneously? And the first thing to check is, are all the angles congruent? Because that is the first, or one of the criteria, and that's the criteria that I like to, it's easiest to check that first. So let's just look at the first example. It says, determine whether the rectangles are similar, and if so, write a similarity statement. So what you're going to do here is, I'm going to start by looking at the small triangle, or the small rectangle. And I'm going to write a ratio comparing the sides. So I'm going to compare the short side to the long side, because these are rectangles. So we know that there's two sets of sides that are the same, and then another two sets of sides that are the same. So if I write a ratio comparing the short side to the long side, it's going to be 30 over 42. And then I'm going to look at my larger rectangle. And I want to write a ratio doing the same thing. The short side to the long side. So which side is the short side of the larger rectangle? The LK, or the 50. And the long side would be the 70. Okay, so the question is this proportional? If it's proportional, their cross products are equal. So we want to look at the cross products. 42 times 50, 30 times 70. And if they're equal, if this is a true statement, then they are proportional. So go ahead and multiply those out. So what's 30 times 70? And 42 times 50? So are they proportional? Yes. So now we have to write, it asks us to write a similarity statement. A similarity statement is very similar to a congruence statement in that we have to write them in a correct order. So I'm going to start with the smaller one. I'm just starting with the one on the left. And I'm going to write the endpoints around this rectangle in alphabetical order. So I'm just going to draw a little rectangle, because we used to do like a little triangle when it's a triangle, right? So a little rectangle, A, B, C, D. Similar. Do you know the symbol for similar? What do we use? Yeah, it's a little squiggly thing. So you might put that up at the top. So rectangle ABCD is similar to rectangle. So AB, if I'm looking at that, AB is a long side, right? So I have to start my second rectangle with a long side. It doesn't matter which one in this case because they're both the same length. So I'm just going to do LH. And then I can go around and do JK. So once you start it, you can just finish around the polygon. Because BC, our next 2 points here, form this side, which is a short side, which also corresponds to HJ, the short side of my longer one. Any questions there? You see how we're doing that? Writing the statement and then checking to see if it's proportional. So if you cross multiplied and these were not equal, then your answer would be no. And you cannot write a similarity statement then if those cross products are not equal. So let's look at the next one. It says find A so that the 2 rectangles are similar. So kind of what that language means is assume they're similar and let's find the value for A that makes them similar. Okay? So we're going to set up a proportion like we did up above. We're going to look at the small rectangle, or the one on the left, and I'm going to do the short side over the long side and put that equal to the larger one, the short side over the longer side. So kind of the same thing we did up above, only now we're missing a piece. So it's kind of like we were doing in the box. You're going to actually be finding that value that makes this true. So short over long, 2 over A equals short over long, so 3 over 12. So we're supposed to find that value for A. So go ahead and do your cross products and solve for A. Solve for A. So this is just like we were doing in the box. Thank you. Actually, isn't that covered there? The middle one. Anyway. Okay, so let's cross multiply. 3A times 2 times 12 is 24. Divide by 3. A equals 8. We can't write a similarity statement here because they didn't name the rectangles. Okay, any questions? Let's look at another one. Okay. So this one says that these two triangles are similar, and then what they want us to do is find x. Okay. So we're going to take our smaller rectangle, or our one on the left, and I want to do short side over the long side, and then I'm going to do my larger rectangle, the short side over the long side again, right? Just, we don't have to write that out every time. So, do short over long. Equals short over long. So I have to do the short side over the long side. Now this kind of gets into that third example that Ms. Dodson was doing on the box, right? Stand up if you need to. Okay, okay. So cross products, right? I'm going to do 7 times 2x plus 2 equals 4 times 4x plus 1. Let's distribute. Seven times 2x is 14x. 7 times 2 is 14. 4 times 4x is 16x. And then 4 times 1 is 4. Gather x's up on one side, numbers on the other. So, what do you want to do?
You want to subtract 4 from both sides.
Subtract 4.
And you want to subtract 14x.
Wait a minute. 14x plus 10 equals 16x. So I get x equals 5. Okay, any questions there? Okay, so let's look at one with a triangle. Triangles make things a little different because it's not as easy to see like short side and long sides. Because look at these. I mean, there's an obvious short side, I think. But the other ones in the picture don't quite work the same. Okay? So, look at the angles. Can we figure out what this angle is over here? All of these need to add up to 180, right? So if we add these two together and subtract it from 180, so if we do 49 plus 57, and then subtract that from 180, we do get the 74. Now over here, what do we get for this angle? 57 plus 50 plus 74, and then subtract that from 180, 49. So that tells me that it's possible that these are similar. Okay? Well, actually, it says find them so they are similar. But knowing that the angles are the same is your first step. They have to be all the angles the same. So now, how do we set this up? Because I can't really go just long over, short over long and like that. But, okay, let's start with any one of the sides. Well, no, I want to start with this one, the one that I need, right? This side, it looks like it's our short side, right? But it's also the side between the 57 and the 74. So which side over on this triangle is between the 57 and the 74? This one. So that's your first side. So I'm going to do the pink first in the numerator. And then it really doesn't matter which side we go to next. Let's do this one. Between the 74 and the 49. Between the 74 and the 49. So I'm going to do that one second. So I'm going to do the pink side. I'm just going to put this one over here first. 44 over the green side, 56. And then here, X over 42. How do you solve for X? Cross multiply. And then divide by 56. Okay, any questions there? One more thing. Kind of asking back to what we asked about in one of the original things. So first thing we want to do, it says determine if the polygons are similar, and if so, write a similarity statement, similarity ratio, and a similarity statement. So here, we first of all have to decide if they're similar, right? So that means we need to know if all of our angles are congruent. So let's figure out in this triangle, what would that angle be? $70? And then what would the angle be in this one? Okay, so as long as they're the same, then that's kind of check the first box. So now the second thing is let's check to see if they are similar. So pick one side to start with. The side between the 70 and the 53. So that's this side here. Okay. And then, which other side do you want to do?
42 and 15, or 30,
57.
So the one between the 70 and the 57? And the one between the 70 and the 57. So let's do pink over green. Equals pink over green. Cross multiply those and see if they're similar.
4 minutes, man.
Okay. Are they similar?
Yeah.
Yeah, these are the same, aren't they?
Okay.
So now we can write a statement. So I'm going to do the first one. MNL. I usually say do it in alphabetical order. I'm like ignoring my own rule. It really can be started anyway. I just did it, so we did green to pink. So I'm going to do the same thing here, green to pink. Triangle RQP. We will talk about this similarity ratio piece tomorrow.
You'll notice I use 6 periods paper for 5th period, so.
Oh, no, you're fine.
And then I'm going to steal your sheet after you do it again. Because that one I get to, so I don't think I need to write it out. I think I'm good. I did there. So I was like, where is he going? I realized that he was doing. I think I'm going to create one of those things, the bot sheets for my other class too. I kind of like it. That way I don't have to talk to them as much when they come in. They just look at it and go. I don't know why they do this. I mean, it's going to ring right now, but still. Why do you have a glove on?
I got it. Hey, yo.
I'm not even hearing. See, I'm just waiting for your response.
Maybe. I got it from biology. I'm an experiment.
So you just wanted to wear it? Okay. All right, Michael. Get it?
Chemical.
Michael's my favorite.
It's just
Shouldn't even get it.
easy. Actually, we're on documented it has chemicals in it.
Oh,
Poison. We work with poison. Also, these are not even saying that.
Let's hope they're not. You're still recording, Miss Myers.